Introduction. Today we learn isomers and concepts used in organic reaction mechanism. Anybody knows about isomers? Anyone? No? Okay, I will tell you. The organic compounds which have same molecular formula but different configurations are called isomers. The examples of isomers are dimethyl ether and ethanol. They have same molecular formula but different configuration.
Teacher, what is reaction mechanism?
Reaction mechanism is a sequence of steps during which chemical reactions occur. In this lesson, you will learn isomers and fundamental concepts in organic reaction mechanisms. Objectives. At the end of this lesson, you will be able to describe isomerism and its types, explain fundamental concepts in organic reaction mechanism. Isomerism. Existence of sets of two or more compounds with same molecular formulas but different configurations and hence different properties. The compounds are called isomers. Different types of isomerisms are: isomerism can be grouped into structural and stereoisomerism. Structural isomerism can be subdivided into chain isomerism, position isomerism, functional isomerism, meta-isomerism. Stereoisomerism further categorized into geometrical and optical isomerism. Structural isomerism. Structural isomers are the molecules which have the same molecular formula but have different arrangement of atoms. Chain isomerism. Chain isomers have same molecular formula but have different order in which carbon atoms are bonded to each other. Structural isomerism. Position isomerism. This isomerism is due to the difference in the position of functional group in the same chain, is termed as position isomerism. Functional group isomerism. They have same molecular formula but different functional groups. Metamerism. This isomerism arises due to non-uniform distribution of carbon atoms on either side of functional group. For example, methyl propyl ether and diethyl ether. Stereoisomerism. Stereoisomers have the same molecular formula and same connectivity, but different orientations of their atoms in space. Stereoisomerism can be grouped into geometrical and optical isomerism. Fundamental concepts in organic reaction mechanism. Organic reactions are chemical reactions involving organic compounds. The organic molecule is also termed as substrate, reacts with attacking reagent, and forms intermediate and then the final product. A reaction mechanism is the step-by-step sequence of elementary reactions by which overall chemical change occurs. Fission of a covalent bond. A covalent bond may be broken by two ways: heterolytic cleavage, homolytic cleavage. In heterolytic cleavage, the bonding pair of electrons remains with one of the two fragments between which the bond is broken. For example, all carbocations have a positive charge on the carbon atom. Classification of carbocation. Primary carbocations. In this, the carbon atom which carries positive charge is attached to only one alkyl group. These are also called 1-degree carbocation. Secondary carbocations. In this, the carbon atom which carries positive charge is attached to two alkyl groups. These are also called 2-degree carbocation. Tertiary carbocations. In this, the carbon atom which carries positive charge is attached to three alkyl groups. These are also called 3-degree carbocation. order of stability of carbocations is: a carbanion is negatively charged molecule that induces a carbon atom with negative charge. The simplest carbanion is the methide ion, can be derived from methane by a loss of proton. Homolytic cleavage. When a covalent bond breaks in such a way that each atom retains one electron of the bond, the process is called homolytic cleavage or homolysis. It often produces free radicals. The movement of single electron is shown by a fish hook arrow. Nucleophiles and electrophiles. The reagents which are electron-rich, such as chloride ion, are called nucleophiles because they seek centers of positive charge, that is, nucleus. Nucleophilicity can be defined as the tendency of an atom to donate electrons to an atom. The reagents which are electron deficient, such as carbocations, are referred to as electrophiles. Electrophilicity can be defined as tendency of an atom to accept electrons from an atom. Electron movement in organic reactions. Curly arrows are used to show the movement of electrons. The tail of the arrow indicates the location from where the electron pair is shifted, and the head of the arrow indicates the location on which the electron pair is moved. Movement of single electron is indicated by half-headed curved arrow. Electron displacement effects in covalent bonds. An attacking reagent can be positively or negatively charged. Therefore, the reagent will attack a substrate only when the substrate develops an opposite charge and the substrate can develop some polarity by the displacement of electrons. Such displacement of electrons in the substrate molecule is referred to electron displacement effect. Inductive effect. It is a permanent displacement of electrons which originate due to the difference in the electronegativity of the two atoms. Let us consider a chain of carbon atom in which the terminal carbon atom is joined to a chlorine atom. Chlorine is more electronegative than the carbon. Therefore, the electron pair in the covalent bond between the chlorine atom and C1 atom will be displaced towards the chlorine atom, due to which chlorine atom acquires a small negative charge and C1 acquires a small positive charge. Now C1 is slightly positively charged, so it attracts the electron pair, forming covalent bond between C1 and C2, due to which C2 acquires a small positive charge, but the charge is smaller than that on C1 because the effect is passed from C1 to C2. Similarly, C3 also acquires a small positive charge which is smaller than the charge on C2. This type of shift of electron along a carbon chain is known as the inductive effect. The symbol I is used to denote the inductive effect. The groups which are electron withdrawing, they are said to cause negative I effect, and the electron releasing groups are said to cause positive I effect. Resonance structure. The structure of some compounds cannot be represented by single Lewis structure. For example, toluene. Resonance structures represent two or more Lewis structures that differ only in the placement of their electrons. Organic molecule, benzene, cannot be represented by a single Lewis structure as it has alternating single and double bond. The structure of benzene ring is resonance hybrid of structures first and second, called resonating structures. Another example of resonating structures is acetate ion. The energy difference between the actual structure of resonance hybrid and the lowest energy resonance structure is called resonance energy. Following rules must be applied in writing resonating structures. the same positions of nuclei, and the same number of unpaired electrons. Resonance effect. Delocalization of pi electrons over more than one atom is termed as resonance or mesomeric effect. It is symbolized by capital R or capital M. It is of two types: positive resonance effect, positive R effect. This effect is shown by the groups which release electrons to the rest of the organic molecules by delocalization of pi electrons. For example, aniline. Negative resonance effect, negative R effect. This effect is shown by the groups which withdraw electrons from the rest of the organic molecules by delocalization of pi electrons. For example, nitrobenzene. Electromeric effect, E effect. When a compound containing double or triple bond is exposed to attack by an electrophilic reagent, the electron pair is transferred completely from one atom to another. The atom to which the electron pair is transferred becomes negatively charged and the other atoms become positively charged. This is a temporary effect. As the reagent is removed, the organic molecules revert to their original state. The effect which causes temporary polarization in a substrate molecule containing a multiple bond by shifting of an electron pair from one atom to the other under the influence of an electrophilic reagent is called electromeric effect. Types of electromeric effect. Two types of electromeric effect: positive electromeric effect, positive E effect. If the pi electrons of double or triple bond are transferred to that atom to which the reagents get attached ultimately, this effect is called positive E effect. For example, addition of acids to alkenes. Negative electromeric effect, negative E effect. If the pi electrons of double or triple bond are transferred to that atom to which the attacking reagent does not get attached, this effect is called negative electromeric effect. For example, addition of cyanide ion to the carbonyl group. Hyperconjugation. Delocalization of sigma electrons through sigma pi or sigma p overlap known as hyperconjugation. The sigma bond in conjugation with the pi bond or sigma bond in conjugation with the p orbital participates in delocalization and thus stabilizes the system. For example, in propene there are 3 CH sigma bonds of CH3 group which are in conjugation with the pi bond. The sigma electrons are transferred to adjacent carbon-carbon bond and pi electrons are shifted to terminal CH2 carbon. 3 contributing structures are possible for propene as it has 3 CH sigma bonds. Due to participation of sigma electrons in delocalization, the bond between carbon and hydrogen does not exist in contributing structures, due to which hyperconjugation is also referred to as NO bond resonance. Did you know? In the hydrogen molecule, the sigma bond was formed by the overlap of 2 1s orbitals. Moses Gomberg is the founder of radical chemistry. Summary. Let us summarize what we have learnt. The compounds with the same molecular formulas but different configurations are called isomers. Types of isomerism are structural isomerism and stereoisomerism. A reaction mechanism is the step-by-step sequence of elementary reactions by which overall chemical change occurs. A covalent bond may be broken by heterolytic and homolytic cleavage. In heterolytic cleavage, the bonding pair of electrons remains with one of the 2 fragments between which the bond is broken. When covalent bond breaks in such a way that each atom retains 1 electron of the bond, The process is called homolytic cleavage. Nucleophilicity can be defined as the tendency of an atom to donate electrons to an atom. Electrophilicity can be defined as the tendency of an atom to accept electrons from an atom. Inductive effect is a permanent displacement of electrons which originate due to the difference in the electronegativity of two atoms. Delocalization of pi electrons over more than one atom is termed as resonance or mesomeric effect. The temporary polarization of an organic molecule containing a multiple bond due to the shifting of an electron pair is called electromeric effect. Delocalization of sigma electrons through sigma pi or sigma p overlap known as hyperconjugation.